Good morning, everyone. Good morning, ma'am. Today, I'm going to explain about the propositional versus first order inference. Let me introduce myself. My name is K. Nagaprasanna, bearing a roll number 23401 A0477. Subject name Introduction to Artificial Intelligence. Subject code 23CSM 509. Here is the introduction. Introduction to logical inference. Logical inference is the process of deriving new facts or conclusions from known information using rules of logic. It forms the core of artificial intelligence, knowledge representation, and automated reasoning. Inference mechanism help computers mimic human reasoning, enabling decision making and problem solving. Two fundamental logical systems used for inference are propositional logic PL, first order logic FOL. Understanding the difference between these two logics helps in choosing the right framework for reasoning tasks. Propositional logic. What is propositional logic? Propositional logic deals with statements uh, that are either true or false. Each proposition is treated as a simple atomic unit without any internal structure. Uses logical connectives like and, or, not, implies, and biconditional. Example propositions. P. It is raining. Q. The ground is wet. Complex expressions or formal like P is implies to Q and P implies to Q. Inference is done using truth tables, resolution, and equivalence rules. Characteristics. Characteristics of propositional logic operates on truth values of complete statements. Does not deal with the internal structure of components of propositions. The domain is finite and fixed. Each variable represents the specific statement. Knowledge representation is simpler but less expressive. Inference is based on synthetic manipulation of symbols using formal rules, suitable for reasoning about simple fixed situations without quantifiers or relationships. First order logic. What is first order logic or predicate logic? First order logic in FOL extends propositional logic by introducing quantifiers, variables, and predicates. It allows expressing relations between objects and properties of objects. Includes quantifiers. For all, universal quantification. There exists existential quantification. Example, all humans are mortal. Here we use for all x, human of x, that implies mortal of x. There exists a student who studies AI. There exists student of x and studies of x comma AI. Here is x is the student here. FOL provides a more powerful way to represent real world knowledge. Here are the components. Components of FOL constants represent specific objects like, for example, John, Phi, India, etc. Variables representing general entities that are X, Y, Z. Predicates represent relations or properties. For example, loves of John, comma Mary greater than X, comma Y. Functions map objects to objects. For example, father of John is equals to Peter. Quantifiers for all and there exist to express universality or existence. Connectives and or not implies etc. Similar to propositional logic, these components allow expressing complex statements about objects and relationships. Inference in propositional logic. Inference in propositional logic. Inference is based on truth table evaluation and logical equivalence. Common inference methods include modus ponens. If P tends to Q and P are true, infer Q. Modus tollens. If P tends to Q, negation Q are true, infer negation P. Resolution used in automated theorem proving by eliminating contradiction. Algorithm like um, DPLL and truth table checking are used. Works effectively for small scale, well defined logic systems. Inference in FOL involves unification and instantiation. Resolution principle is extended to handle quantified statements, inference rules to known facts. Backward chaining works backward from a goal to find supporting facts. FOL inference is computationally complex but much more expressive. Enables reasoning about general rules, relationships, and objects in a domain. Comparison propositional versus first order logic. Here are features propositional logic, first order logic, basic unit proposition, and here is the predicate. Variables not used, and here x, y, z, etc. are used. Quantifiers here in propositional logic, there is no quantifiers available, but in first order logic, we use for all and there exist. Expressiveness here is the limited expressiveness, and but in first order logic there is a very high expressiveness. Inference simple and mechanical, and but here complex but more meaningful. Applications or circuit design simple rule systems in propositional logic. In first order logic there are knowledge representation, AI databases, etc. Knowledge scope. In propositional logic, finite and specific facts or knowledge scope. In first order logic, infinite and generalized status. Applications. Applications of both logics. Propositional logic, digital circuit design and verification, truth maintenance systems, game logic and basic decision system, etc. In first order logic, artificial intelligence and machine learning reasoning, uh, semantic web and ontology representation, natural language processing for semantic understanding, summary and conclusion. Summary and conclusion, propositional logic provides a foundational of reasoning with simple statements. First order logic builds upon it, adding variables, quantifiers, and relationships for deeper reasoning. PL is computationally efficient but less expressive, whereas FOL is expressive but computationally heavier. Thank you. Thank you for giving me this.